Hello, we are group 3 and we will be doing problem 3-43 in the textbook today. This is our truss made out of marshmallows and this is our truss on the board. We are solving for members KJ, NJ, ND, and CD. And we're going to show you two different methods today, how to do it. The traditional joints and sections method, like method of joints as well as method of sections, because you kind of have to use both in this case. And then we're going to go and show a shorter way that works for this problem that might be helpful in tests or something. But either way, you have to start with solving for the reactions, which is the global thing. And so we're going to start by solving for the moments at point A, which is right here. And in order to do that, you have to find the forces times distance in one direction, the forces times distance in the other direction. In this direction, we have this force acting 20 feet away, so that would be 1,200 pounds times 20 feet. And then we have 1,500 pounds acting 40 feet away, so 1,500 times 40. And then 1,800 pounds acting 60 feet away, so we have 1,800 times 60. And then in the other direction, we only have gy times 120 feet. So when you solve that, gy equals 1,600 pounds upward for the reaction. And then you solve the forces vertically equal to 0 to get what ay equals, and then you have negative 1,200 acting down, negative 1,500 acting down, and negative 1,800 acting down, as well as the 1,600 from the gy acting upwards. And ay you assume that it acts upwards anyway. And then when you solve that, you get ay equals to 2,900 pounds. The next thing we have to do is we have to solve the triangles to get the angles. This triangle represents these two triangles, which are mirror images of each other. This triangle represents all of the other smaller triangles. And in order to get all of these angles, what we did is sine inverse equals opposite over hypotenuse. And then we got these angles. We got more exact angles that we used the values for in Excel in order to produce all these numbers, but we figured it would be shorter just to write these to give you the general idea. Alright, let's move on to the method of joints now. Joint A is where we're going to start, and that, if you recall, is right over here. And it only has two forces involved, so we can use just the forces equations. The forces vertically are equal to 0, so we have the 2,900, which is the AY, and then plus AL times the sine of this angle, which is 56.3 degrees, I'm sorry. And then we have AL, and then you solve that to get AL equals negative 3,400 pounds. And because it's negative, that means it's in compression for truss member. Then we're going to solve the forces horizontally are equal to 0. And we have AL as well as AB. So it's going to be AL times the cosine of this angle, because it's just that. It's on the diagonal, so you can't use the whole thing, and AB is straight, so you don't have to multiply that by a cosine. And then we can plug in the value from AL that we got up here to get AB equals 1,900 pounds in tension, because it's positive. Let's move on to joint B. The forces vertically, we have only two forces, BM and 1,200, which was the applied load. So 1,200 acts down, BM is assumed to act up, and when you solve for BM, equals 1,200 pounds in tension. And then, because it's positive. And then the forces horizontally, we have AB acting in this direction, BC acting in this direction. So it's minus AB because it goes towards the left, plus AB because it goes towards the right. That's just the sign convention. So when you solve that, you get AB equals BC equals 1,900 pounds in tension. Then we move on to section 1, which is just a cut through the truss, like in the middle of these members, LK, MK, MC, and BC. And then we're going to take the moment about point M, which is the point in the midpoint of this member here. And, well, it's really two members, but it's the midpoint of this line. Why we take that is because we already know BC, we already know this, we already know this. These points are these two forces are concurrent with point M, so the moment doesn't go through there. So the only unknown force is LK in this situation. And so we have in this direction 1900 times 15, because that's the distance from here to here. And then LK times 15 is on the other direction. And then 2900 times 20 is 20 in this direction. Well, and then we solve that to get LK equals 1900 pounds in compression because it's negative. Then from that, we could solve the forces vertically and then the forces horizontally. And this is going to give us a system of two equations with two unknowns. So we're going to have to solve it. This is going to be your first equation, and this is going to be your second equation. And from the second equation, you get that MK equals minus MC. So we plugged that back in, and then we had 2 MC here because it's the same. Getting that MC equals 1,400 pounds in tension. And then you plug that back into this one, and you get MK equals 1,400 pounds in compression because it's negative. Then we move on to joint C, where we're going to solve the forces vertically. And we have Cn acting up, Cm acting up, times the sine of that angle, and Cn, and then the 1,500 pound applied load acting downward. When you plug in Cm, which we already know, we call it MC over here, but it's the same force, you get Cn equal to 650 pounds in tension. Then we're going to solve f sub x equal to 0, and that's going to be this one times the cosine of 36.7, and then minus this because it's to the left. Oh, it's minus this as well. And then it's plus CD. And that's going to get us CD equals 3,000 pounds in tension. Alright, now we're going to move on to the last section we have to do, section 2. And we're going to do something similar to what we did in section 1. We're going to take this time moments about point N to get KJ. And so we have 1,200 pounds acting this way, and it's 20 feet over. CD is acting this way as well, and it's 15 feet this way. And then acting in the other direction, the reaction of AY times 40 feet, and then KJ times 15 feet. And these two, once again, don't act because they're concurrent with the point N, like the forces go through there. Then we have f of x equals 0, and f of y equals 0 once again, and two equations, two unknowns, which we have this pointing up, this pointing down for the vertical at least, and then these two don't apply for the vertical, but we have to incorporate this, and this in the vertical equation. And of course use the signs where appropriate. And then in the horizontal direction we have this, and this. And then we'll solve that to get NJ equals the opposite of ND, and plug that in back here to get ND equals 167 pounds in tension, and NJ equals 167 pounds in compression. And that's the solution that we think we're supposed to get. Now we're going to move on to the easier, faster solution.
Here we're going to cover method of sections. It's easier because it saves you time and it's straightforward. Method of sections is just taking a cut through a section and solving for the unknowns. Instead of taking a straight cut, sometimes you can go around the section so you have less unknowns. Like in this case, we're going to start from K, go around the line and go through C. That way we eliminate the need of having to solve for NJ and ND. But at the same time, we can solve for KJ and CD, which are one of the unknowns. So as we do that, that, we move on to here. In this page we already have solved for the unknowns, the reactions at A and G, like she covered over there, so I'm not going to go through that. Over here, we start with taking the moment around C. Now it's easier if you start from the point, go to your unknown force, and then turn you on for the moment arm thing. So from C, we're supposed to go to KJ, and this distance from here to here is 30 feet. So since our positive is counterclockwise direction, we start from C, we go to KJ, this is clockwise, hence the negative sign up here, and then 30 feet. And then the two given forces, from C to B is 20 feet. Again, it's going to be clockwise, so it's negative 2900 plus 40. And then same thing here with 2900. So that way we come up with the only unknown in here is KJ. We solve for it, we get negative 3066 pounds. Now since this answer is negative and we assume it to be in the tension, that means that our initial answer is incorrect, so it should be in compression. Now we go to point K here, and similar way we solve, we take the moment at K, and then the known forces involved are FCD and 30 feet, 1200, and then 2900. Solving the same equilibrium equation, we get same answer, except we get a positive answer in this one. That means the force we assumed in the initial case is the same one. That means this is going to be in tension. Sorry about that. Now, since we already have two of our equations that we're supposed to find, these are the four we're supposed to find. Now, we already solved for these two. Now, the second section we take is through the line between KJ and CD. That way, the only unknowns we have are NJ and ND. Now, in this case, we don't actually have to use equilibrium equations like taking moments, because it's straightforward, just adding the forces in the vertical direction. So if you add the force in the vertical direction, you get negative 1500, negative 1200, positive 2900. And then you can solve for the vertical reactions of these two forces, since those are the only two unknowns. And you can use this angle because you know the distance between the vertical distance here and the horizontal distance here. So doing that, we get Fnj times the sine of 36 for this here, and for Fnd, the vertical reaction, and the three unknown forces. Solving that, we come down to this equation, and if you use simple algebra, you get with this equation, these two are like negatively related. Now, using this similar equation, if you plug it back in here in this above equation, we come up with this expression up here. And if we solve for, since you have just only one unknown, one equation, it's straightforward to go and solve for that. And since the answer is positive itself, and which is the direction we assumed in the diagram over there, we get 0.167 kips in tension. For some of you who don't know what kips is, 1,000 pounds equal to 1 kip. So, there we go. And since we already solved for Fnd, the only unknown we have is Fnj, you can go back to the equation down there that we solved for, and just use the expression we had found, the Fnj equals negative Fnd. Solve it back into the equation, and we get a negative answer, which means it's supposed to be in the direction opposite to the one we chose earlier. So it should be in compression. Now this was a much straighter and simpler way, although some of you already know how to do the method of joints. So in case you want to save time, you can go through method of sections. Now if you want to check your answers, you can do the exact same thing in the diagram. Since this is a symmetric diagram, if you cut it in half, it's going to be the same. It's going to give you the same answers on the other side. So you can follow the similar directions we just did, solve for these equations, and they should match up with the answer we just got in this case. And if you guys have any questions, we'll be in Jake's tomorrow in happy hour.